All right, 2.6, we're going to look here a little bit more at linear functions, see a few more things that we can do with them and expand upon that idea of linear functions. Okay, so let's look at a couple definitions. So our first one is actually going to be a little bit of a reminder, kind of break it down to some specifics, and that is what we call the intercepts. Now, we've already talked about the y-intercept, and so let's just do a little reminder. We have the y-intercept, and that's where it crosses the y-axis, and we even looked at the ordered pair when we were using those, and that was always 0, some y value there. Okay, and so we always have that one. So if our graph crosses the y-axis, that's going to be our ordered pair. But we can also have it cross the x-axis. So that's called the x-intercept. And that's going to be x, 0 with it. Remember, the x is in that location in the ordered pair. That's why the x and y switch positions there on those. Okay, but we still have a 0 involved. It means the y value is 0 in this case. So we can use those to be able to do some graphing, because to graph a line, we only need 2 ordered pairs. So I have 2 ordered pairs right there. So we can use that. Okay, now it doesn't work for every possible single line out there. There are some times that we don't have an intercept on both cases, or they're the same intercept. But we're going to look at some specific situations where it does work. Okay. A couple other definitions here. Parallel lines. Okay, so parallel lines. This is 2 lines that have the same slope but different y-intercepts. Okay, so if they have the exact same slope, you can have the same steepness, but if they're 2 different y-intercepts, they start at different places, they're going to be parallel. They're going to look like train tracks, right? Because that's what parallel lines mean. Okay, so that gives us some information to work with. We're graphing. If we get that y by itself and we see the same slope, we know we're going to be parallel lines. That's going to be important to us. The other one that we want to look for is perpendicular lines. Now, perpendicular, if you remember, that means that the 2 lines cross at a 90-degree angle with them. So that's kind of special. That doesn't happen very often. So we want to recognize that things make that happen. Okay, and so our official definition here for 2 lines: the product of the slopes equal -1. Okay, so if we were to take the slopes of those 2 lines, multiply them together, we would see that it should equal -1. If it equals anything else, if it's +1, if it's some other number, then it's not perpendicular. Okay, and so we'll look for that piece in a little bit. Okay. All right, so let's look at some examples here and see what we're going to do using this information. All right, so let's graph using intercepts. Now, in Pearson, if it gives you specific instructions on graphing, you have to do it that way. Okay, so if it says graph using the points, you have to use whatever points they give you. If it says graph using intercepts, we need to find the intercepts and graph. If it says graph using slope intercept form, you have to do that. So make sure that you read your instructions so that you know which method to use, okay? Because they're looking for specific points. Now, in general, you could use any of the methods, but Pearson does make you use the specific methods. So pay attention to those details when you are graphing these, okay? All right, so number 1 here, we have 2x plus 3y equals 6. Okay. All right, so let's find those intercepts. Okay, so let's start with the x-intercepts. X-intercept. I'm going to use x-int there for intercept as an abbreviation, so to keep us from having to write. Well, if we're looking for the x-intercept, that means if we go back to the definition, that y must be 0. So what we're going to do here is we're going to take and plug 0 in for this y. So we get 2x plus 3 times 0 equals 6. And then we're going to solve for our x value here. Well, 3 times 0 is 0, so that's just going to go away, leaving me with 2x equals 6. So we divide by 2, so x equals 3. So that gives me the ordered pair 3, 0 for my x-intercept. Okay. Well, now we need to do the y-intercept. So it's kind of the same process, but this time the x is 0. So 2 times 0 plus 3y equals 6. Well, the 2 times 0 is going to go away for us, and so we're going to get 3y equals 6, or y equals 2 when we divide both sides by that 3. And so that means that we have 0, 2. Okay. Now that we have those two ordered pairs, we can graph our line. So let's draw a quick graph. 1, 2, 3, 1, 2, 3. I didn't have to go out very far because I only have 2 and 3 there on those. So let's graph our first one, 3, 0. So we're going to go out to 3, 0 here. 0, 2. So we're going to go up to 2. And so then we connect those two dots. And there is our graph. So if we're able to find those intercepts pretty easily, it makes it real simple for us. Okay. Now we do like for them to be whole numbers. Not really easy to do fractions. So we have to be careful with that. But a lot of times they'll come out as whole numbers and give us good information. Okay. All right, let's do another one here. So we have 5y equals negative 15 plus 3x. Okay, so 5y equals negative 15 plus 3x. Now, if you wanted, you could technically move some things around, but we're just going to leave it as is, and we're still going to find our x and y intercept. So let's start with our x-intercept. That means that y must be 0. So 5 times 0 equals negative 15 plus 3x. Now, we do have to be careful. We want to do it this way on a reason. A lot of times we just want to cancel through this, but it does equal 0. And since it's the only thing on this side of the equal sign, we do need to write 0. We can't just make it go away. Always remember that if you start with an equal sign, you must end with an equal sign and something on both sides, whether it's a letter or numbers, have to have something there. So that it cancels out. That really means that it's getting a 0 there when we're adding or subtracting for those pieces and multiplying specifically. Okay. All right. So now we need to solve for x. So I'm going to move that 15 over by adding. So 15 equals 3x. So we divide by 3. So x equals 5. Okay. So that gives me the ordered pair 5, 0. Now I need my y-intercept. Okay, so that's going to give me 5y equals negative 15 plus 3 times 0. Now, because this negative 15 is still over here, that's why we can cancel that out, because it becomes a 0. Negative 15 plus 0 is still negative 15. So that's okay to just get rid of it. So 5y equals negative 15. And then we divide by the 5. So y equals negative 3. So that is the ordered pair 0, negative 3. Okay. All right, so I'm gonna have a lot of room here. I'm gonna squeeze this graph in this little location. It'll be okay. Should be able to see it still. So we know we need to go out to 5. So 1, 2, 3, 4, 5. So we're going to plot that 0.50 and then down to -3, 0, -3, and connect the dots. And we get our line. Okay. So as long as we can plug in those zeros and get out numbers for both of them, two different numbers there, we're going to see that we can plot these using intercepts. All right. All right, let's look at some others. Another style here. All right, so the next one is going to say graph using slope-intercept form. Now remember, slope-intercept is that y equals mx plus b. And so that's the form we need it to be in. We're going to see how to use that, okay? So our first one, y equals 5/2x plus 1, right? Now, the good thing here is that if I get it in this form, y equals mx plus b, it gives me information. It gives me the slope, and it gives me the y-intercept, okay? So if we were to look at those pieces, I'm going to write it out this time. Our slope here, 5/2, that is my rise and run. So we briefly talked about that before. So we're going to make that come into play here now. And then our b is 0, +1, okay? So let's look at how we put that on the graph. So let's draw us a quick graph here. 1, 2, 3, 4, 5, 6, 7. We'll go a little bit further this time. Okay. All right, now we always plot the point we have first. We always need that. Okay, so our point is the y-intercept. So we're going to plot it at 0, 1. 0, 1, there is my y-intercept. Okay. Now our slope tells us to do rise and run from that point. Now positive is always going to go up. I do negative always down. But we only assign that to the top. Our bottom number is always going to be positive. So we're going to always go to the right. The reason why I do that is so that I don't get confused. Should I be going left or right, up, down, all this? I'm going to go, if the whole number, the whole thing is positive, I'm going to go up and to the right. If it's negative, I'm going to go down and to the right every single time. Okay. So this tells me to go up 5 units because it's positive, to the right 2 units. So I'm going to go up 5, 1, 2, 3, 4, 5. I'm going to turn and go right 2, and that's where I'm putting my final location. So up 5, right 2 to drop my second point, and then there is my graph. Okay. Now it's kind of like following a street map. That 5/2 is telling you how many blocks to go up, and then turn right and go that many more blocks before you get to your final location. So think of it like that, okay? When you're plotting those points. But as you can see, it's very simple once we get it into that form. So let's look at another one. Two here. Says x plus 2y equals 4. All right, so we can see this time y is not by itself. So we need to get it there so that it's in the correct form. So let's do that. So to get y by itself, we need to move that x over. So that's going to say 2y equals -x plus 4. I like to put that x first so it fits my y equals mx plus b form. So that's why I always do that. And I'm going to divide every single thing by 2. So that's going to give me y equals, well, remember this is a 1. So when I divide it by 2, it gives me -1/2 x. I have 4 divided by 2 is 2. Okay. Well, now again, we have our slope. We have our y-intercepts. Remember that y-intercept, we take that sign with it, okay? So this time I'm just going to go straight onto my graph. Not going to worry about rewriting that piece. So 1, 2, 3, 4, 5. So we're going to start at positive 2, up to 2. This time, because it's negative, I'm going to go down 1, right 2. Down 1, right 2. And there should be my graph. Now my scale's a little bit off, so not the other points are very correct. I know where it should be going, but that's okay. The computer will fix those things when you're graphing them. So it'll put it in a straight line. It'll have everything scaled perfectly so that my graph looks correct. I probably could have used a straight edge. I think I curved it just a little bit there, so it threw it off a little bit. That's okay. As long as you have those 2 points listed there correctly, then you're going to be good. Okay. But that's how we're going to use slope and intercept. The slope-intercept form of graph. Once we get it there, very simple to work with. Okay. All right, so let's look at a couple of others. These are just going to say graphs. We can use any method we want. We can use a table. We can use slope-intercept, intercepts, or just what we know about them, which is what we're actually going to see we have to use here. Simply knowing some things. So our first one says y equals 3. Okay, y equals 3. So here I do not have an x value, but we do have y by itself. Since y is by itself, we can think about some things. Go ahead and draw my graph. Now, since there's not an x value, I have a number without the x. That is my y-intercept because it says y equals that number. Okay, so we can go up on our y-intercept to 3 and put a dot. But because there's not an x in it, that means it will never touch the x-axis, ever. And so in order to not touch the x-axis, that means it has to be parallel to the x-axis. So you're going to get a horizontal line. So to graph this on the computer, you're just going to pick another point. It does not matter where that second point is, as long as you create a horizontal line parallel to the x-axis. And so there's my answer. And so you just really want to memorize that. If it's y equals a number without an x, horizontal line at that number on the y-axis. Okay. Well, then likewise, if we have an x equals a number, so if we have x equals -1, on the x-axis, we're going to go to -1. X equals -1. And then from there, we would draw a vertical line because it cannot touch the y-axis. And we just pick another point. Again, it can be any point on that line that creates a vertical line. Okay? And so that's what you want to look for there on those. All right, so those are the kind of different styles. So now we have all these different methods to graphing. We have a table. We have x-intercepts, or both intercepts, x and y-intercepts. And then we have slope-intercept. And then finally for here, when it's just y equals a number or x equals a number, it's really just kind of a knowledge piece of being able to throw it up onto the graph and tell what's going on there. Okay? All right, last thing that we need to look at here, though, is a couple more informations, because we did talk about some definitions called parallel and perpendicular. So let's look at those. Okay, so determine if the equations are parallel, perpendicular, or neither. Okay. So are they parallel, are they perpendicular, or are they neither one? Okay. All right, so our first one here. Y equals 3x plus 9. And then our second equation would be 2y equals 6x minus 2. Okay. All right, now in both of those definitions, parallel and perpendicular, we talk about the slope. So we need to know the slope. We may even have to pick out the slope and write it down. That's basically the question. It may be a yes, no. It may be actually writing in some information, okay, and then telling for those, okay? So here our first one, our y is already by itself, so we know the slope. Our slope is 3. We know what that is, okay? Now our second one, y is not by itself, so we need to divide every single thing by 2. So divide by 2, we're going to get y equals 3x minus 1. Okay. Now again, here my slope is 3. So the first question we ask is for parallel. Are those two numbers exactly the same? In this case, they are. They are both positive 3. So since those are both positive 3, and we know that these equations are not exactly the same because the 9 and the 1, since these two are both positive 3, and these are parallel because they have the same slope. Okay, and I'll leave it at that. I won't even make you write that it has different y-intercepts. But on a problem like this on an exam, you will need to get those slopes, tell me what they are. Even if the question doesn't say so, you would need to show me what the slopes are, and then tell me they're parallel because they have the same slope. You got to tell me why are they parallel on those. So that's what you would do right here. Okay. All right, let's look at another one. 2. Okay. Y equals 4x minus 5, and then 4y equals 8 minus x. All right, now again, we need to look at the slopes. We always do that. So here we can see that my slope is 4. So m equals 4. M just did not come out right. But our other one, we need to get y by itself again. So in this case, we just need to divide everything by 4. So y equals 8 divided by 4 is 2. Remember, that's a negative 1. So negative 1 over 4x. Okay. Now that does mean, even though it's written a little bit different, that my slope is negative 1 over 4. Always remember to take the sign with those things in front of it, okay? So always do that. Now, when we look here, we have 4 and 1 over 4. They are not the same. We automatically know it's not parallel. So we need to now check and see, is it perpendicular? So for perpendicular, remember, perpendicular, that means that if I take our slopes, we'll call this M1 and M2. M1 times M2 must equal negative 1. That's what perpendicular means, okay? We multiply the slope. All right, so let's do that. So if we take 4 times negative 1/4, we put that in parentheses so it doesn't, we catch that negative there. When we multiply that together, positive and negative make negative. 4 times 1/4 is 1. So yes, it is perpendicular because of multiplying together does equal negative 1. Okay, and that would be enough work to show me. It said perpendicular means this. We did that work, therefore it is perpendicular for those. Now, if neither one of those two things happen, you would select neither. You would say it's the slopes do not equal negative 1, and they are not the same. So therefore, there would be neither one. Okay, so those are how you would explain those types of problems. All right, so that's what you're going to be doing in this section. You're going to be graphing, and then you're going to be looking at these parallel and perpendicular lines.